In this example, we are going to be trying to find the maximum volume of a box. And the idea is we're going to we're going to take this rectangular shape and we're going to cut off some corners. Now, you'll start to feel like you've seen this before, and it's definitely something that gets introduced in an Algebra 2 class, and then kind of revisited and talked about again in like a college algebra slash pre-calc. So we're going to bring that up. We're going to talk about that piece of it, but then we're also going to say, well, there were limitations in those math classes, and so we need to figure out, is there an algebraic way to actually solve this? And calc is what we needed in order to do this. So here's where we're at, and we'll talk about kind of where we veer off into the calc part. So it says a piece of cardboard measuring 11 inches by 8 inches is formed into an open top box by cutting squares with side length x from each corner and folding up the sides. So we have initially this rectangle that is 11 by 8, and we are cutting corners. And each side is an x. So it gives us this new base that we're going to fold up these pieces because these are going to be gone. So on, on, on. All right, so we're going to have these sides that are going to flip up and give us height. So we're going to be creating some sort of a box that we need to figure out the volume for it. All right, so new dimensions on this, we need a volume formula. So the base of this was 11, but we cut an x and an x off, so that's going to be 11 minus 2x. This was 8, but we cut an x and an x off, so that's going to be 8 minus 2x. So this is 11 minus 2x by 8 minus 2x. And then that height is going to be what we flipped up. So to find the volume, it's length times width times height. So length times width times height. So x times 11 minus 2x times 8 minus 2x. All right, so at this point in a college algebra class, we would have thrown this in, or an algebra 2 class, we would have thrown this in. Well, let's do this. Let's do not so much the algebra 2, let's do more the college algebra pre-calc. So let's get a rough idea of what this thing looks like. So this is a cubic if I do all the distribution to it. Let me go ahead and do all the distribution to it. And so if I distribute this together, I'm going to get an 88 minus 22 and a minus 16, so minus 38x plus 4x squared. And then if I distribute this and I'm going to rearrange it, that's going to get us a 4x cubed minus 38x squared plus 88x. So whether you graph this or you graph this on a calculator, it's going to give you the exact same thing. But I can do a little bit of a rough sketch and kind of get an idea of what's happening by factored form is going to give us my x-intercepts. So my solution to this is 0. This is 4, and this is going to be 5.5. So if I go 1, 2, 3, 4, 5, 6, and I have an x-intercept at 4, at 0, and 5.5, I know it's a positive cubic, and so we would have some sort of a shape like this. Now, big thing is to understand that these y values are the volume, right? And the x value is we are cutting whatever these little corners are, the length of these corners. So what we're shooting for is this point. So that point, the x value is going to be our best cut to give us our biggest volume. This gives us negative volume. Makes no sense because you're looking at a value greater than 4, which is a problem right here. So if that's 4, it's 8 minus 8, so you have a dimension of 0. If you plugged in 5, now you cut more than what the length was, right? You can't cut 5 inches on each side when you only have 8 to work with. So you have a region from here to here that's even going to make sense. And so what you would have done in a college algebra class or a trig class or a pre-calc class is we would graph this, we would get some sort of a look to it, There it is, right? There's more of an exact answer. And then we would go to the calculator and we would find the maximum, right? And so that's all you were able to do because you didn't have the math that's actually going to figure out the maximum to it. So here's our cut. Here's our cut. Here's our volume. So I have an answer, but let me show you how Calc's going to get that answer. So Calc is going to do the derivative. If we do the derivative of it, then we're going to be talking about zero slopes. And we're going to have a zero slope here, and we're going to have a zero slope here. That's not the one we want. That's the one we want. So what that's going to give us is that's going to give us our x value. It's going to give us perfectly our x value. That's that same x value that you would have saw in the calculator. So we do our derivative, and we have a 12x squared minus a 76x plus 88. We'll take that, set it equal to 0. So 12x squared minus 76x plus 88 equals 0. I'm going to try to help my own cause here. I can divide a 4 out of every single piece, right, as long as I'm dividing it by everything. So that's going to get us a 3x squared minus 19x plus 22 equals 0. I was really hoping to try to find if this thing factors. It does not factor. So my plan B is quadratic formula. So it's a negative 19 plus or minus square root negative 19 squared minus 4 times my A times my C, all divided by 2 times A. All right, so I shoved that into the calculator. I've got two answers. One was I did the plus, and I had a 4.808 and some change. And then my other answer was 1.525 and some change. That and some change I'm going to make sure that I use, but I need to round it at some point. But I'm going to be using it as accurate as I can on the calculator. And so this answer right here is past, we cut too much. It's going to give us this, it's going to give us that zero slope. So I don't want that one. I want that one. So that is representing that x. So my graph is not perfect. But that's the cut that I would want to make. So that's one of our dimensions. That ends up being the height. What I need to figure out is find the dimensions of the box that would have the maximum volume, and then what is that maximum volume, right? And then we'll round it all off. Okay, so first off, in Calc, now I know, like, I have my visual, I know it's got to be a maximum, but Calc usually is going to still ask, how do you know for sure that that's a maximum? Like, am I 100% sure that that's actually what the graph is, or maybe it goes down? So here's how you can do very quickly. Let me justify it with some Calc. So I have this critical point of 1525. And then what I'm going to do is take my slope equation. Doesn't matter if I take this one or the simplified version of it. And I'm going to plug in a value to the left. I'm going to plug in a value to the right and see what kind of a value I get. So we can even do that. We'll do it now. If I plug in a value to the left, we're going to plug in a 0. If I plugged 0 into all of these, I would get 22. So I'd get a positive. So that whole section would be positive slopes, which agrees with anything less than that 1.5 something is positive slopes. And then over here, we should get negative slopes. So if I plugged in like a 2, I would be having 4, 12, 22. I'm going to not quite have enough because this is going to be negative 38. I'm going to be a little bit less. So I'm going to get a negative out of that. So I have positive slopes transitioning to negative slopes. That's my Calc justification. It's that transition in slopes from positive slopes to negative slopes guarantees me that I have to have a maximum, which agrees with my graph. Okay, so that's telling me that this is going to be my maximum cut. So now I just need to do my work to get my dimensions. So my dimensions are, I already know that that's one of the dimensions. And then I would have taken my 11 minus 2 times that 1.5 525 and change. And then I would also take in, because that's getting this side right here, then I'm going to be doing 8 minus 2 times 1.525 and change. All right, so I'd be throwing those right into the calculator using all the value on that. And that gets me, when I put all these pieces together, I'm going to have a 1.525 inches by, this one turns into 7.950 inches by, this one turns into 4.950 inches. And I'm actually going to 3 decimal places rather than 2. So those are my dimensions. So that's part of my answer. And then the volume that I get, I'm not using those. I'm going to be using the calculator pre-rounded values. So I would be using the 1.525 times the 7. It ended up being 7.949 times 4.949 So I'm going to use all that decimal times all that decimal times all that decimal to be as accurate as I possibly can. And I get a maximum volume of 60.013 if I cut it off at 3 decimals. So if I go back to the work that the calculator did, it gives me that same thing of 60.125. That 5 rounds me to a 3. And I would have seen that exact same decimal in everything. I would have had the 2, the 5, the 6, and the 3 when I multiplied those 3 values together. So that's as accurate as I can get it with this calculator. So that was kind of an algebra 2 pre-calc, and then we are justifying, like, here's how you actually do the math using calculus to get what the calculator just tells you.